Hello. Oh, hello.
Good morning.
Oh, sorry. I was having a cat had a pooping, vomiting disaster, and I was
Super fun.
yeah. I have one sick cat that is trying to die, and then this is the other cat that my son says there's poop in the foyer, and then I hear vomiting in the basement, and then I'm trying to catch her and end my. I was trying to finish recording my previous Zoom. It's been a morning. So sorry. Kitty that is trying to die is actually eating now and seems to be better. So yeah. So hopefully she's getting better. So yeah. Okay, yes. When you're here, type here. Let me get out your sheet. Let me just go ahead and type when you're here. Let me see. Okay. All right, good. Everybody's getting in here. Okay. So yeah, sorry, I didn't mean to. I had to attend. Hopefully you guys are doing okay. I don't need to be recording this. What am I doing? Let me go ahead and get started here. I did, hopefully when you guys took the test, let me just mute. I think nobody's really saying anything anyway, but I'll just mute everybody. And again, if you just got in here, type here. But when you took the test, for any true and false question and for any fill in the blank question, I put the answer that I was expecting, like why the question was false. So that my little answer is supposed to release once the grades release. So hopefully you guys were able to see what I was looking for. So I don't know if you have any big questions from the test, but one thing, a couple that caused some confusion, I'll just briefly, because I already said it in the email. The dog that was in surgery, and I said they're tapping on the eye, they are looking for what's called a palpebral reflex. So you need to give me, I know people call it the blink reflex, but the proper name is the palpebral reflex. What you're looking for is a blink. That's what is supposed to happen. Now, the animal was under anesthesia, so there is a potential that that dog doesn't blink, but everybody was pretty much right in telling me we are assessing anesthetic depth. So obviously, if a patient is anesthetized, they lose certain reflexes, and that helps us know that our animal's at a good anesthetic plane. The other question, so a lot of people put PLRs, but that's the pupillary light reflex. When you do a PLR, you're not looking for blinking. We're mainly just seeing is the pupil dilating and constricting. It's an indicator of brain function, not sight. But if the brain can sense light properly, it should constrict, and the other pupil should do the same thing. And so that's what we're looking for, PLR versus palpebral. The last question, and hopefully everybody understood what I put in the email. This happens sometimes as you guys get to know me. Sometimes I write a question, or sometimes when I grade a test, I realize maybe I didn't get my point across, or maybe, and I take responsibility as a teacher for something like that. It's like maybe I just didn't stress this enough. If I have everybody getting one question wrong, that's kind of a red flag that maybe I didn't, do something. But there was stretch reflex, withdrawal reflex, and I said list a location in the body that would respond to the stretch reflex. Now, the leg, or when you hit the knee and the leg, the muscles stretch and contract. So a lot of people had put leg, stifle. I had a couple people put bladder, and what I was really looking for was like bladder, stomach, lungs, because what happens is those areas, the nerves detect when they stretch, and when they reach a certain capacity, they send a signal to the brain, and the brain will initiate a response. So if it's the bladder, it's going to try to constrict and empty the bladder. If it's the lungs, when you inhale, they stretch, and then it initiates exhalation. And then when they compress, it initiates, that's how we get inhalation, exhalation, is the monitor. There's a lot of things, we talk about that next term, but there's a lot of things that go into inhalation and exhalation. And then stomach, obviously, once the stomach stretches to a point, the brain should send a signal to say, stop eating. Now, we all know that we push ourselves, and we have dogs that will just eat and eat and eat. But in a normal response, that stretching of the stomach should stop the animal or us from eating. And then obviously when the stomach compresses, and then obviously we start to get hungry again and we eat. And so if you get what I'm trying to say. So if there's no other questions from the test, those were the main issues I saw on the test. If I go up through the test, now I believe I have left the test open, so you should be able, to go through and, again, we are just getting to know each other, but I'm very fair in grading, and I'm very fair that if a student put an answer, they felt very strongly about it, and they talked to me about it. I'm like, if you can prove your point to me, now, not always, but a lot of times I'm reasonable. I'm always trying to give you points. I'm not trying to take away points. So if for some reason you look at your test, you didn't maybe agree with something, or maybe I caused confusion, I'm very willing to discuss it with you or to go over it again. So, so if there's no questions, let me go ahead and open up. You should have received this PowerPoint last night. It was attached to an email. Let's see if I can open it up. Okay, my computer is just being dumb. I don't get it. There we go. Okay, hold on. You guys went away. Wait, where did you guys go? I did not hear. There we go. Okay, I was like, all of a sudden I can't see you guys. Okay, so we are starting the bones in this section. This is a lengthy PowerPoint. It's one of the longer sections that we do, but there are a fair amount of resources online. There is a very good purpose game for the dog skeleton. So when we get to that picture, I will explain, and I will try to send you guys some extra stuff. I will get this homework out to you this afternoon, and I'm going to just go ahead and go forward. And again, type a question if you have it. Okay, good. Yeah, hopefully I had a little issue here. Okay, so speaking of the bones, and I don't know, maybe by now you have done bone terminology. There we go. Maybe you have already done this in terminology, but anytime you have os as a prefix or in the word, this is pertaining to bone. Osteo is pertaining to the bone. So obviously, a site is a cell, so an osteocyte is a bone cell. When we talk about bone cancer, it's osteosarcoma. Sarcoma is a suffix, and sarcoma can be very different types of cancers. So there's osteosarcoma, hemangiosarcoma, perisarcoma, so there's different, but anytime we put osteo in front of it, it's going to be pertaining to a bone. Interestingly, this word here, os penis, the canine actually has a floating bone. It has a little bit of a groove in it, and it goes under the urethra, and so they do have a bone under their penis, the dog, and that bone is called the os penis. Most of our bones are attached together and are attached to muscles, but there's a few bones that I will talk about that are floating bones. The hyoid bone, the os penis, so they're not attached to the skeleton, they're kind of in, but I will tell you the majority of the bones connect to one another. Okay, this is weird. I don't know why it does that. But second hardest natural substance in the body, and really, when we talk about what the bone is made of, this is composed primarily of osteoblasts and osteocytes. Now, if you remember, a blast is a foundation cell, and I said foundation cells don't travel anywhere in the body. They are where they are. So an osteoblast is remaining in the bone, and it is creating osteocytes. So the blasts are the immature form, and the osteocyte is the mature form. What they do is they will harden and create this substance. When a bone forms, it is called ossification. Let me give you an example. When a dog gives birth, and when the puppy is first born, in utero, the structures of the bones are cartilage. Growth plates in a bone are cartilage. When a bone starts to grow, those cartilage structures are going to harden or ossify. And that is when the cartilage turns to bone. Now, part of the ossification process is creating these things called lacunae and caniculi, and that's part of the bone structure when it hardens. But I do want you to know what ossification means, but it's literally basically the hardening of this bone structure. If we have an animal that breaks its leg and it has to heal and become firm bone again, the doctor might say, oh, the bone has ossified. And that basically means that the bone or the callus has formed, the bone has healed, and it's hardened that structure over the fracture. So that's ossification. Now, I always, in every section, talk about what's the function of this type of thing we're talking about. Obviously, bones give support. You wouldn't have a skeletal frame without that. They do protect. You have a rib cage, okay? So your thorax is surrounded by vertebrae and ribs, and that protects the heart and the lungs. You have the vertebral column, and that supports and protects the spinal cord. So bones are going to protect. They're harder, and they're going to give protection sometimes to softer or more delicate structures underneath. Leverage, it gives us the strength when your muscles, when you go to like lift something or pry something open, it's going to allow the leverage, your muscles, to move against something so that they can actually function. Storage is interesting. Now, storage, the bones, obviously, we know calcium. Everyone talks about you need calcium to have strong bones. The body, in times of need, can access stored calcium. When we talk about the endocrine system next term, there's a couple different hormones that keep our calcium in balance. So in times of hypocalcemia or low calcium, we have hormones that can actually draw calcium from the bones into the blood. Now, obviously, we don't want to do this continuously because you obviously, the bones need their calcium. It's not like we're drawing everything out, but we can access calcium. The body can take excess calcium from the blood and force it into the bones for storage. So it can work both ways, in hyper, which is high calcemia, or hypo, which is low calcemia. So again, when I talk about that later, we'll get into that. One thing that's very important is blood cell formation. So the maintenance of the red blood cells in our body is called hematopoiesis. Hemato is meaning pertaining to blood. Poiesis is production of. So hematopoiesis is the production of blood cells. Now, this becomes important later, because I'll get into erythropoietin, or specifically the production of erythropoiesis, which is red blood cells. But the bone marrow is inside the bones, and your red blood cells, your white blood cells, they don't live forever. Okay, a red blood cell is going to go into circulation and it's going to die, and the body has to be continuously supplying red blood cells. And that is, there's a connection between hormones and blood cells and the bone, but you need an active bone marrow to be able to supply red blood cells. So I will be getting into that for sure a little bit later. The bone itself has two specific structures. If this is a bone that has been cut in half, if you look at the picture, see this white, firm outer bone. That dense, heavy bone is called compact bone. So the outer, if you held a bone in your hand and you looked at the outside, that would be compact bone. So it's smooth, it's hardened, it's very dense. It's made up of very tiny cylinders of bone, but they're very compact together. That's why we get the term compact bone. There is something called cancellous bone. This bone is light and spongy. It's sometimes called spongy bone. The scientific term is cancellous, but sometimes people will call it spongy bone. I will tell you that sometimes during fracture surgeries, and when I was a surgery tech at Purdue and we did a lot of different surgeries, the doctor can open up another portion of the bone, sometimes in the shoulder or the hip. The doctor would go into that bone and scoop out some of the own patient's cancellous or spongy bone, and then they would put it on the fracture site, because that spongy bone will help, that cancellous bone will help the fracture heal. It's called a bone graft. So anytime we do a bone graft, now there are companies that make synthetic bone graft material. You can buy it, it comes in these little tubes. We open it sterilely during surgery, but it's a little bit better to get it from the actual patient. You just have to make a little incision, scoop it out of the bone, put it in another location. But so sometimes you'll hear about a cancellous bone graft. They're literally scooping out some of that spongy bone and putting it in another area. That will heal back up just fine. If you think about a kitchen sponge, and it has like the tiny little holes in the sponge, that's literally, think about this looking kind of like a sponge, and then it being surrounded by this denser compact bone. Okay. Now, the cancellous bone, which again is our spongy bone, I do want you to know the term cancellous, okay? I prefer on a test that you would put cancellous and not spongy. It's tiny little spicules with spaces between them. Again, think about the tiny little holes in the sponge. There's a little space in between. So if you look at this picture, inside you kind of see these holes. And this is where, in the middle of the bone, we're going to talk about, this is where you have the bone marrow. So the bone marrow is, and most of the bones in the body, not just the long bones, even some of the vertebral bones, flat bones, do have a component of bone marrow in them. Now, again, these spaces allow the cells to go in and out. So, you know, red blood cells have to be able to leave the bone marrow and go into circulation. So you can see there's blood vessels in the bone. When you look at a bone, it just looks like a white, hard bone. But technically inside that bone, there are blood vessels. Now, the spicules have an arrangement, so hopefully when there's pressure on the bone, it still maintains its structure. It's not, even though it looks spongy or tiny little holes, it's not going to fall apart, okay? Again, if you're just getting in the chat, I see my numbers are going up, so make sure you type here in the chat. If you've already done that, you're fine, but just make sure I know that you're here. So here again is a close-up picture. Okay, this outer core here, where these Haversian systems are, that is the compact bone. Oh, you're fine, Ariana. I just want to make sure that I don't miss anybody. But this outer is the cortex or the compact bone, and then this inside is the cancellous bone, and then you have blood vessels here. Now, if we look at what compact bone looks like, and remember I said it's tiny little, these like channels, or kind of like canals, but they're very tightly packed. But this compact bone is the outside layer of all bones, all shafts of long bones. So when you see a bone, you are literally, what you're looking at on the outside is compact. They have these things called Haversian systems. They run lengthwise with the bone. So they run long ways. If you look, it looks like they're pulling out one of these Haversian systems. So they're like kind of concentric or circular tubes, these Haversian systems, and then they have tiny tubes within. They are concentric layers, concentric meaning going in a circle, and then you have layers of these circle. So these Haversian systems are these concentric layers, and they all kind of seal together. They're all surrounding a central canal of the bone. So you have these concentric layers, and they surround the inner canal, which is where we're going to talk about the bone marrow is. Inside these compact bone, you're going to have blood vessels. And again, I've not done circulation yet. We do that next term with cardiovascular. But you see there's red and blue. Anywhere there's red, it's an artery, or it's an arterial, which is a tiny artery. It's bringing oxygenated blood to the area. And the blue is a vein, or a venule, which is a tiny vein, and it's going to bring deoxygenated blood out of the tissues and eventually goes back to the heart. And that's the process of circulation. So anytime you see a picture of a vessel, you're going to see red and blue because they work together. And then there's going to be lymphatics and there's nerves. If you look at what one of these holes look like within the Haversian systems, they're showing you up. There's an osteocyte here. There's these caniculi, lacunae, which are kind of like the channels. And then we've got these Haversian systems. And what they do, well, let me get to the next slide. That'll make more sense. Okay, what you're going to look at here is you've got an Haversian system, and there's something called the Volkmann canals. The Haversian systems and the Volkmann canals almost make like an H, but what it is that those Volkmann canals allow these blood vessels to connect to one another. So you've got the Haversian systems and then these canals that allow the blood supply. What this is, think of this like a piece of cake. If you cut into a bone, I've just pulled out a piece, and you're looking, this is the outside, this is the frosting side, and then you look into the middle of the cake. All these little holes here, this is your cancellous bone, or your spongy bone because it has holes. So this is the inner part of the bone, and we're working our way out. And then you're going to see this thing called periosteum. Okay, so right under here you have compact bone. or this whole thing right here is compact bone, super zoomed in. Every bone has a layer of something called periosteum. I think of it like a peel. If a bone was a banana, the peel would be the periosteum. So if you think of it that way, you peel a banana, the banana and the outer part of the banana that you're going to eat is the compact bone, but you removed the peel, which is the periosteum. So if I look at it up closer on this next picture, this is like cut in half and we're kind of looking down at the bone. So if we cut the bone in half and we look down, you can see here is that cancellous bone. Here is the compact bone. And then this is the peel. Now, there's obviously an inner and outer periosteum. I just want you to know that periosteum is a membrane that covers the bones. Think about the banana peel as a membrane that covers the banana, if you think of it that way. Now, peri, hopefully, I can't impress enough upon you guys how important terminology is, because understanding your terminology helps you figure out different things in different classes. But, peri means around. So we know periosteum is like the peel around the bone, peri-peel. Endo means within. So endosteum, which is this word, is what lines the marrow cavity. So it's the inner lining of a bone. So there's endosteum, which is found within the bone. Periosteum is found around the bone. And that's the difference between peri and endo. Get to the next. Now, the foundation cells that I just talked about, the two primary ones is the osteoblasts form the bone. Okay, they're the foundation cell. Osteocytes are going to be osteoblasts surrounded by bone. But remember, an osteocyte is more mature. So as an osteoblast forms the bone, the osteocytes are going to be the mature form of that bone. Okay. There's one cell that I hadn't really talked about, and that's called an osteoclast. Now, a osteoclast, basically can remodel. Think about clast clay. Think about how you model clay. When you guys get into the classes like ClinMed 4 I'm teaching now, we're literally talking about fractures. When a bone breaks and we put it back together, what's going to happen here is the bone's going to form something called a callus. A callus is this immature form of bone, and it sometimes is lumpy bumpy. A bone will heal in about 8 weeks, but over the next 16 to 24 weeks, osteoclasts are going to come and eat away or remodel and reshape that callus, and it should turn back into normal smooth bone. So sometimes owners will say, and this is especially aggressive in puppies, puppies heal, if they break a bone, it heals sometimes within 6 weeks. They're young. And sometimes the healing is very vigorous. Sometimes if it's too vigorous, they'll get this bump, and the owner might say, well, there's this big lumpy bump over the fracture. Well, a lot of times that's just a very aggressive callus formation. And then what will happen several months down the road, technically, if there's a good callus, that bone is healed, but eventually we want that bone to go back to that normal, smooth appearance, and that's what an osteoclast does. So I just do want you to know the difference between the blastoclast and the site. They're all found within bone. Now, when I showed you on that previous picture is the bone, even though it looks very hardened, there is a very good blood supply to bone. Obviously, because the bone marrow is making red blood cells, they got to get out of the bone and to circulation. So you need a good channel of blood supply to allow the movement of that blood. And that's through these Volkmann canals. And so you can see these are blood vessels, and they are within, remember, a Haversian system is kind of like this up and down. The Volkmann canals will connect the blood supply through that hardened compact bone. And that is how the blood goes in and out, in and out, in and out. Now, there are things that we are going to, there's like common words or common parts to a bone. Every bone has something called, well, I'm sorry, not every bone, but the very large, long bones have something called a nutrient foramina, or some people call it a nutrient foramen. Anytime you hear foramina or foramen, and I want you to remember this, it is a hole in a bone. Sometimes you'll take an x-ray of a dog, if the dog is big enough, or sometimes the x-ray will pick up like a hole. And someone might say, does this dog have a hole in the bone? Did it get shot by a BB? Is this actually a fracture? I mean, that is always a possibility, but more than likely what you're seeing is one of the nutrient foramina. Because remember, all these Volkmann canals and Haversian, like all that blood has to exit out of a main spot. So typically, anytime you hear foramen, it's a hole in a bone. The nutrient foramina, think about blood as nutrients. And we want blood to get in and out. We want red blood cells to leave the bone to circulation, but we also need nutrients like oxygen, minerals, electrolytes to get in the bone, because the bone is a living tissue. So we have to get blood supply in and out, if that makes sense. So really what the nutrient foramina does is it carries blood in and out of the bone marrow. But never neglect, we're not only trying to get blood out of the bone, we're also trying to get nutrients from the body into the bone. And all blood supply is an in and out system. Okay, blood comes into tissues, blood has to leave tissues. Nutrients and oxygen come in, wastes and like byproducts leave. And in this case, red blood cells leave, which is a good thing, okay? But the blood supply is always in and out, red and blue, in and out. But anytime, I'm gonna talk about the foramen magnum. That's basically the big hole in the back of the skull that allows the brain stem to leave the brain and connect to the spinal cord. So magnum, or thinking big, foramen magnum is a hole, and what comes out of that hole is basically the spinal cord and the brainstem. Now, some blood supply and nerves as well, but that is a very large foramen. But you know, the brainstem is large, spinal cord. So just remember that basic foramen, hole in a bone, foramina, hole in a bone. Now, before I get to this next section, I think this is a good place to stop because I know you guys have math coming up, and I want to get into this. Gets a little lengthy and wordy. So what I will do, I'll stop at this spot. Later this afternoon, I will send out some materials. So be looking at your email later. And I'll try to send out some stuff. And hopefully everybody got this PowerPoint. Okay, so there's gonna be lots, I will tell you, your lab book, you know, there are probably gonna be some exercises in the lab book, but the lab book of this section is gonna have a lot of pictures of these bones. It's gonna, you know, remember I said, your main reading always comes out of your main textbook, but the beginning of every lab chapter has kind of a little summary, and sometimes it gives a more simplified explanation and a lot of pictures of these things. So I would definitely make sure you're reading, I mean, both the lab reading and in the textbook. And it's just the chapter on the bones. So if you don't have any questions, I will go ahead and